Hello and welcome to this video about device code phishing. This video is about this lab from Pwn Labs. However, you could just use it to learn about phishing and about, in particular, lateral movement in Azure, in Azure engagements and in Azure environments. And so, let's begin. So we start with the website, aka the domain of the company, who we are eventually going to be phishing. So let me give you a little look. In my little diagram that I made about this lab, we start with this company, international-am.com. And before I get into how we know that this is a Microsoft Azure web application, let's first talk a little bit about having the domain and what that means for us in terms of OSINT and how to advance further. Well, there are a couple ways to firstly enumerate what we can find externally and publicly. We could just do a little bit of DNS and NS lookup in order to find the IP associated with that domain and that website. And we can also use Recon NG. Recon NG is very powerful, not just for company enumeration, company OSINT, but also profiling. The profile module is extremely strong in that it finds the username or email in all and any social medias. So Recon NG is really something to look at as well whenever you're in a situation like this where all you have is the company name. And like I said, DNS stuff like DNS enum, putting in the company name and using a big word list such as this top 1 million subdomains list. We find international.com, protection.outlook, also indicating that it's in Azure. And of course, we get the IP over here. And so let's go ahead and navigate to this. So as you can see, it is a web application. And since we did get an indication from that Outlook domain that it's on Azure, why don't we go ahead and confirm by using the publicly accessible identification of tenant IDs. So if we go to any sort of website or any way that you want to do it and insert the domain name, you can find the tenant ID very quickly over here. And here we got the tenant ID indicating that yes, in fact, it is on Azure. Now we have that ID over there, which we will use in the future. So before we delve into this website, I just wanted to note that we can start fuzzing and undergoing the standard sort of protocol for web applications. However, in order to save time in this video, I'm going to focus on the key learning outcomes, which are phishing, internal enumeration, lateral movement, and a little bit of Windows exploitation. However, I will show you from here that we can use things like FUF to fuzz, we can use GhostSpider to crawl it so we don't have to click manually and things like that. And also we can even scan the website IP with Nmap just to make sure if there are any other ports or any other attack vectors involved in this. But now that we're here, let's go ahead and look at the key focal point of this website that grants us the point of initial access, aka the phishing campaign. And so if we go here and we go to contact, I believe it is, and as per the standard protocol of just enumerating a website, you just act like a normal user using the functions that it has. And that's not it, so let's see, where is it? Client portal. Okay, so we try to log into the client portal and we get this support email. And so with this email, we can then try to undergo the phishing technique. And so that's what we're going to do. However, let's first talk a little bit about phishing and about successfully phishing through emails. So with this, we have a target. We have this support email. The support user behind this email is who we're going to be trying to phish. However, something else that we found on the website is also services. We also have, besides these services and people in these services that are being shown, we also have the executive team. So we have profiles, we have people that we can look at, people that we can research, do some OSINT, see the faults in their OPSEC, see if their IT team has anything juicy, anything that we can use in order to make this phishing email more successful. So going back here, we have these, and we craft a little phishing email using as much OSINT as possible and as much data that we can find as possible. We use this phishing crafting. We craft it. We get the tenant ID as I showed you how to get it, and then the method that we're going to use in order to grab this person's access, knowing that they're on Azure, they probably have their Azure account logged in. If not, they can probably log into their Azure. With that in mind, our target point and what we're trying to gain from this user is their Azure access. And so there are a couple of ways to do this. Now, I know that the lab guide says that you can just do AZ login with the device code option and then get the code that way, and that way you log into AZ. However, firstly, I want to take you through the most optimal methodology, which is to get the refresh token. If you just get access with the device code, then that's great, but that's great for a limited amount of time. The refresh token, however, lasts for much, much longer. And so getting the refresh token off that successful phish is going to provide you with a lot more access in the long run, utilizing the different tokens that you can get from that refresh, etc. And so how I'm going to do that is with Sato. So using this code, you can kind of take a look at it and look up Sato and go to their GitHub and all that. But long story short, this is the command here that is going to give us the device code that when used, we get an access token, a management one in specific, and a refresh token alongside it. So let's go ahead and do that. Let's close this stuff. Let's go to Sato. Is clear a thing? Okay. All right, awesome. Pull up my email. So as you can see, we got this code over here and we got this link. So if we issue this user to go to this link and put in that code, then we'll be able to catch that refresh token. All right, so here is the email. I'm going to try to make something reasonable. Access required urgently. No. Click for your um, click to access bonus. Time limited. So John over here has to access his bonus, and if he fails to do so, that's it for him. He doesn't get his bonus. Okay, John just got this job. He needs this thing bad. Um, So one thing about the link is that you can shape it to be however you want. So in reality, this is device code, but here it could be, www dot um, winprizenow.com. And now him clicking on winprizenow.com will take him to that login page. Him being in a mindset that, okay, I need to log in order to win this prize right now. He won't think about, okay, this is Azure. What does this mean for my company? What does this mean for my access? He's just going to log in thinking, oh, I guess maybe I have to log in to use the browser or something. You know what I mean? So we put the real code over here, ensuring that the code exists. Kindly log into winprizenow.com with this code before authorization expires. We got to place that urgency. Failure to comply may result in an account suspension. And then we got to put in that penalization, that punishment, where the worker is going to see that and he's going to initially he's going to feel all that heartache and all of that fear, and then that's going to urge him to comply. Not only that, but we also added Mr. Tanaka over here. If you looked at the website, you'll see that Mr. Tanaka is actually a where is it? So Mr. Tanaka, Dan Tanaka is the CFO. And so that's a big dog in the company. So we're going to use his name. Thanks, IT security team, international AM. And we got to throw in, those symbols, 2024. It's all great. So let's go ahead and send this bad boy and wait for our access. I will see you guys if we get that token. Just going to pause here real quick. All right, so here we are. We did get the tokens. And as you can see, instead of only the access token over here, we also get that beautiful primary refresh token. And so this is going to be able to provide us with access for all tokens instead of only getting the management access. So let me show you how that's done using Find Me Access. Find Me Access is a great tool for token manipulation. So we got to get accustomed to using it. Paste the refresh token in it. By the way, if you notice how I made my commands, they're perfectly copy pastable, and so that's great for learning. Oh, I did not get the right token. This is the right token. Okay, this is my second attempt here. We got another refresh token, so let's see if it works. Oh my god, is that why? Yeah, that has to be why. So I put the Mega Big Tech as the domain, but maybe I need to put this Okay, awesome. So sorry for that mistake, but even though international dot dash am is has the same I believe has the same client ID, um, or rather tenant ID, even though that we need to put the international dash am.com. So that's some learning over there. And so as you can see here, we got all of the tokens. However, in order to show you both methods, I am still going to get the AZ login access. So just logging into AZ normally with the flag of using the device code and doing that. We get the code and the link as always. You go ahead and copy that and send another email. Just for the sake of learning, I'm going to do both methods. Learning other methods. And so if you're experimenting with this, please make sure to make this link an actual clickable link by pressing this insert link button. And that way your user will be easy to click it. And in this case, the automated user clicks it when it's like this from my experience. Let's go ahead and send that. And so while that's happening, by the way, now we have a bunch of tokens. So why don't we use something? Why don't we go ahead and grab where is it? The graph token over here. And so this is quite convenient. Instead of just having the management token through AZ login, we can grab this graph token and go to graph runner, and on graph runner you can go ahead and insert this token, parse it, and behold, we have a bunch of information about this user that we got. As you know, the graph API is holding the majority of information about users, groups, things like that. And so now with this access, whilst we're waiting for the AZ login thing to finish, we can go ahead and list all the users. See if this works. Oh, there we go. Got all the users, list the groups. We got groups. Maybe we can fetch some emails. Let's see if we can fetch our users' emails. Go through their inbox. We can send something. Go ahead and test that. Send an email. Message sent successfully. Fetch a team chats. You can maybe send a message in Teams. Do like a mass phishing technique over here. Okay, let's see if this finished. So this didn't finish, so I'm gonna go ahead and oh, there we go, it finished. But you know, if it didn't finish, I'd be like, attention, log in here with this code now. And of course, you know, it would be a lot smarter than that, but I'm just giving you the idea. You send that, you can list the channels. And so you can do a bunch of stuff here just by clicking around and some graph access for you too, all using that refresh token instead of only using AZ login. And so let's go back over here. Now that we got access, instead of just AZ login as well, let's use all the different standard protocols of authentication. So we got AZ login, we got the access token, which got us the graph access. But let's also use the connect-az account login method, which grants us access to management. However, it is very nice to have multiple methods of access in case one doesn't work for a certain command. You can then use the command of the other one. Go ahead and put the management token in here. Let's get the management token. Here we are. Management token, and now we can sign in to connect AZ account with the token option. I'll show you the command here in a sec. So we got connect AZ account access token flag in order to utilize the token instead of credentials or instead of device login. So we put that token in there, specify the user that we're going to access and his tenant ID. Great, and so now we can use my favorite command, which is get AZ resource. And as you can see, we got some resources that we have access to. Now let me go ahead and show you my diagram where I put all of these resources. Firstly, we have this international asset manager, which as described in the terminal, it is a static website. As you can see here, Microsoft, the resource type is microsoft.web/static sites. And then we have security director IP, which as you can guess is an IP address, and it's a public IP address. And then we have security director, which is a virtual machine, and security director IP, which is another public IP address. And so here in my diagram, we can see all that illustrated. We have the VM here issuing this command for VMs. We can also see it again with a little bit more information. Security director in the ISTA's standard V2 size, and it's a Windows machine. And then we have these two IP resources over here, which we can then use this command to see a little bit more info. And as you can see, we get these two IPs. After zooming out a little bit, we see that their IP addresses are as follows: this one and this one. And so if you have the mind of a hacker, you're obviously saying, we have to nmap this right now. And so let's grab the nmap command over here. Go into our trusty Kali and launch that bad boy. And so yeah, in terms of the VM that we found, it's crucial for us to find the user data of it, because VMs, just like in AWS, have user data, and oftentimes that user data have very convenient things for the IT guys that they just put in there in order for things to run more smoothly. Similarly to the launch scripts and things like that, we can find very confidential information like credentials and all that juicy stuff. So let's go ahead and use the native API call method in order to get the user data, because we can't adequately do it with the access that we have and the convenient commands that we're using. So instead, when we get really technical, we're going to want to use the API method, the REST method, invoke REST method. And so as you can see here, we got the user data down here. User data equals this base64. So we grab this and we go ahead and we unbase64 it, which will yield us the clear text user data of net user remote assist is active. So we have this remote assist user on the VM that we're enumerating, and he's listed as active. And so that's good to know. We have a user. If we want to do any brute forcing attacks, anything like that, we are now scoped down to just having to find the correct password, which is great. So let's go ahead and move on with our enumeration. We're getting the nmap of that. We have the user data, and we have AZ login over here, which can yield us info. And let's go ahead and see just some general info about this static website. Okay, as you can see, it's just reiterating what we already know. And another thing about hidden sort of attributes and things, such as where we found in the VM there is hidden user data. Here we can also find information just like that, but in the settings. So let's paste this settings command, az static web app settings list, and then put the name and the resource group. And so as you can see, we get a database connection string. This database connection string in the settings includes the name of the database, the host name of the database. It includes the port of the database, and most importantly, it includes this ID equals admin and password equals int am-pass123, whatever. And so this is critical. However, I know that your first instinct is to try to access that database, but unfortunately, the database does not exist. And so if you want to make sure, we can go ahead and test that over here. I have it over here as well, and it's lookup. And so the database does not exist. However, if we move further through our enumeration, we now have database creds, and we know that this user exists on a VM, and on that VM there are public IPs. There's a public IP that we nmapped. Where's my nmap? So the nmap is still going on. However, to speed things up, I'll give you the result of that nmap is that we see that this IP has the port open 5985. And so 5985 is the port of the protocol Windows Remote. And so if we now have the ability to communicate with the Windows Remote protocol to a Windows host, and we have a password and a user. So, well, in that case, let's go ahead and try to authenticate with what we know through evil win RM. Great, so that worked and we are in. So now let's go ahead and see who we are. And in fact, we are security, we are remote assist in the domain security direct. And so with that in mind, let's get into some basic enumeration, starting off with listing the users. We see that there is a user called James underscore local. And this user, we cannot access his directory. However, we do find something juicy going into the root directory. And just listing over here, we see that there's this directory called download security reports. And so going in here and listing, we find these two files. Now with these two files, as you can see, there are there is a timestamp over here to 14/20/25. And if you look down over to the bottom right of my screen, you'll find that this is today. And so this timestamp indicates that there is something going on here all the time. To put it in the lab instructor's words, in the lab instructor's words, where is the lab instructor's words? Here it is. You would see a directory that is there, and the timestamp of the downloaded file is always within 5 minutes and clearly downloaded using the binary that's there. And so in order to find the attack path of the fact that this is a scheduled task, we would have to be aware of these times over here. Understanding that this time aligns with the current time is indicative of the fact that there is a scheduled task being ran over here, being ran constantly. And so with that in mind, we can assume that this executable is being used in order to download this zip file and constantly updating this security zip file that shows a report on security. And so just like with any scheduled task, we're going to want to replace the executable with a malicious one in order to get further access. Perhaps the scheduled task is being ran by a more privileged user. And as to the fact of whether or not we can do that, we can go ahead and check the permissions of it. And as you can see here, it says that for authenticated users, which we are, there is this M flag, and this M flag stands for modify, meaning that we are able to modify it. We can delete it, we can make it, we can do everything we want. And so with that being said, let's go ahead and make the malicious version that we want to make. And so a little bit about the connectivity issues that people are going through. We need to utilize a publicly accessible resource in order for this to work. And in my situation, I used AWS. So I'm going to go ahead and go into my AWS here. And I'm going to make the payload and utilize Metasploit all on AWS. And so if you're not familiar, what we're planning to do is we want to make a payload to replace this executable, a payload that goes and calls back to our Metasploit framework C2, and by doing that, we'll get the access of the more privileged user that ran the scheduled task. And so we made the payload over here. And now let's transfer this over to the target. Start a little Python server. Before we continue, I actually want to show you that if you're going to be using a publicly accessible resource like a VM on a cloud service, you're going to need all of these ports to be specifically specified in your firewall rules, which in AWS are in the security groups. And only then can you be doing stuff like this where you use port 8888. It might seem random, but I specifically made this open just to do this. And I'd also made other things that are open such as HTTPS, HTTP, and anything else that I need. You have to change it in the firewall rules. Actually, let me go ahead and show you about that. So let me go ahead and just show you all of this. And so if you make an EC2 here in order to do this lab, you can do it with a free tier. I did it with Kali and I'm paying for it because it's Kali, but if you make a free tier Amazon Linux or an Ubuntu Linux on free tier, you can also do it that way and it'll work. And after you do that, you go ahead and go into security groups and access the security group of your virtual machine. And I'm going to show you very briefly the rules that I placed so you can replicate them if you want. But in order to do all of the phishing labs, or any of the labs really, you need these rules. So I would replicate these if you're trying to do all of the Pwn labs. So we got HTTP, SMB for other phishing labs, HTTPS for anything kind of C2 related and stage payloads, etc. SSH for me to connect and use it. Custom TCP, custom UDP. This is my 8888 for transferring things and using custom servers and things like that. And then we have this, the UDP, and these are all for the SMB labs that I'll show you in the future as well. We use SMB to steal somebody's credentials. And that's for the security group and the firewall stuff, so I really hope that that kind of makes you able to do the lab if you're experimenting and on doing stuff on your own. Let's go back over here. And let's go ahead and transfer the payload. Going back into our WinRM. Gonna copy paste this and then explain what's happening. Oh, whoops. What the heck? Sorry, this is what we're pasting. All right, awesome. So before I explain that, I'm just gonna make sure that my MSF is listening. So I need to do that before my malicious executable is replaced, just because that's an automation that the lab instructor made. And then I will go ahead and explain all of the commands. Okay, so firstly, we remove the original executable. After removing the original executable, uh, we remove the original executable in this directory. This is because somebody else might have put it there, and we need to remove it in order to move the original executable that we currently have over there. This is just as per the lab instructions, but I included the remove so that you can continue using the lab instructions without any difficulties. And then we use this import module command in order to download our malicious file from our Python server. After that, we change the permissions of it, and after that we should be good to go, and the scheduled task user should be able to run it no problem. Let's wait over here for the user, and it looks like we got the interpreter session. So let's go ahead and go into that. So as you can see, we got access to James Local as it says here in the information. However, if you want to confirm within the shell, you can go ahead and use get UID, and you'll see that we are in fact James Local. And so yeah, from here you can go ahead and do standard Windows enumeration stuff, checking for what you can do with the newly found access with this lateral movement. But in terms of the lab itself, it ends here, as you can find the flag very quickly with the search-f flag.txt command. And thank you very much for watching, and stay tuned for my next two videos are also going to be about the phishing labs. Thank you very much. Please subscribe and comment and like, and see you later.